All right, now let's discuss about hard disk 3. This disk is used when system is out of physical memory. So swap usage means there is some memory pressure, whereas ESXi is not able to provide enough memory to our VCSA appliance. Okay, so if that short-term swap usage is visible from our command prompt, then it is acceptable. Okay, for a short duration time, due to some memory pressure, the swap file came in, and then again it came out. Okay, but if the swap usage is sustained for a long period of time, then automatically we'll face slowness issue on our vCenter. Okay. Normally, like if our vCenter is undersized or undersizing vCenter, like it's a rare case. Mostly in production, if ESXi is not able to provide or the vCenter load got increased, at that point of time, this swap file will kick in. Okay. Swap is a symptom, it's not a future. Okay. So just keep that in mind. So let's like understand this swap partition with some commands. Okay, let me go into that vCenter. So last we stopped with this option, right? So there is a command called swapon-show. Sorry, I think we are in root. Okay, swapon-show. This command, okay, will explain like what device is being used for swap. Okay, what device means like here we have our hard disk 3, right? See here, we have our hard disk 3. This hard disk 3 has been used for this particular swap disk. That's what this device DM-13 points. This is a device mapper block device. Then the type is partition, because like why it mentioned type as partition is sometimes like an file can also be used for this swap kind of stuff in Linux. Okay, then size is almost 25 GB. Okay, and used is some 122 GB has been used here. Sorry, 122 MB has been used here, and priority is -2. Okay, so here we got some idea. Okay, our swap is an partition and it has a size of 25 GB. Okay, and used is just 122 MB. Let's try to understand why this swap priority exists here. Okay, so memory, like in Linux, memory in Linux is a combination of both the physical RAM as well as swap space. When RAM starts filling up, what the kernel will do, it moves the inactive memory pages from the RAM to the swap file. This is what the normal process which happens at the backend. Why it's doing like that? Because it has to keep the applications running instead of crashing. If swap is not there, what will happen? Our application, vCenter application will get crashed. Okay, that is the reason we have this swap option. Okay, now we need to understand why do we have swap priority and why it is mentioned as -2. Rest of the information we are able to understand clearly, right? This is a device, this is partition, then size used. Okay. So normally in Linux, okay, we have we can configure multiple partitions. Okay. For that multiple partitions, we can define some priorities like which swap partition has to use first, which swap partition has to use second. But from our vCenter perspective, here we have only one swap partition. Okay. And the default priority value has been marked here as -2. Okay. Because in Linux, -1 has been reserved for some purpose. Okay. And that is the reason this -2 or the default value which got allocated automatically here. Okay. See, normally in Linux, they will provide some explanation about this swap priority, which is not there in our ESX service center. So from the Linux perspective, you can find the swap priority value starting from 0 to 32,767. Okay. And using that numbers, if you have multiple partitions for your swap, in that case, you can point those numbers. So whichever is having the highest priority, that is going to serve as the swap partition initially. Then the next, once it got full, the next one, like that, the priority will move on. Okay. So here, as I told you, this -2, it's given uh, by the Linux oriented configuration automatically. So -2 has been automatically assigned as a default number. Why it's not assigned as 0 or -1? 0 to 37,000 something I mentioned, it is user defined. This is system defined. System defined starts from -1. So -1 is already reserved for some other purpose. Okay, so that's the reason it started off with -2 because we have only one swap device in our vCenter appliance. Okay. So you no need to give any high importance to this priority of -2 because swap priority are matter, like it matters only when multiple swap device exist. With one swap device, priority is not relevant. Okay, and we no need to give any importance to this -2 priority option at this level. Okay. Next, we'll move to the next command. Okay. So to understand the swap in a better way, so there is a command called free-h. Okay. So let me explain this output because this free-h has two outputs. One is related to memory, another one is related to swap. Okay. Now first look at the memory. So here total memory is 20 gigabytes. Okay. And free looks like 2.6 GB is free, and buffers cache is almost 4.4 GB. Okay, and available is almost 6.1 GB. So here, from the physical memory perspective, this available memory is the key point for us because this available shows out of 20 GB, 14 GB is already used, and we are left with 6 GB. Then we have enough memory on our vCenter server. In that case, the swap file usage should be very low. Okay. So I hope you understand the first physical memory option about the usage. The second one is very important for our swap partition understanding. Here, swap partition has been configured as almost some 25 GB, right? Total swap is 24 GB. Then used it is showing us some 122 MB. Okay. And free almost the full 24 GB is completely free here. Okay. So here swap is used only for 122 MB out of 24 GB. Okay. That is, like acceptable. This explains that swap is exist here. Okay. And swap is not that much highly used in this vCenter appliance. In that case, it is very clear that there is no memory pressure from the ESXi side. Okay. So free-h, it used to conclude that system is healthy and swap usage is normal. Okay. So that is the use case of this free-h command in the production support. Next thing, we are going to use a different command called vmstat1. Okay. So let it run for another 10 seconds and then we'll stop it. Okay. So we have a command called vmstat1. Okay, this shows the real-time behavior. Okay, so if swap usage is high and we want to investigate deeper, at that point of time in the production support, we will be using this command. Okay, so here there are two key points which we need to take into consideration. One is this SI, another one is SO. Swap in, swap out. Okay, these are the two things which needs to be taken into consideration. So here, when I execute this command, okay, initially there is some swap usage which started again, like swap out as given that again to the memory itself. Okay, which states that the swap usage is very low here. Okay, after the initial command, see here, SO S0, it's completely 0, 0, 0, 0. Okay, which states that there is no swap in and swap out as activity has been happening on this vCenter currently. Okay, so initial value is I executed this command, right? So initially it the memory has spiked and then it caused this swap in swap out. Okay, but after that swap in swap out is completely zero. Okay, so what is SI? SI means swap in data moved from the disk to RAM. Swap out means data moved from RAM to disk. Okay. So on the first line only, we are able to see some swap activity. Rest of the lines are, like SI and SO are 0. So it's very clear that